Okay, so our next speaker is John Delaney. Now, John is a telecoms industry analyst with over 40 years experience in the sector. I often refer to 3G, 4G, 5G. I heard about 6G yesterday, and I haven't really got a clue what I'm talking about. I don't know what a G is. So hopefully this is about to change. So John's talk is titled 5G, the mobile network goes to work. So over to you, John. Thank you very much.
Thank you, David, and let's see if we can fix that for you. So yeah, a lot of noise about 5G at the moment, as well as some other Gs, and I'm going to spend the next 10 minutes trying to give you a flavour for what it's all about. Well, the UK was one of the first countries in the world to get this fifth generation of mobile network technology. 5G started here nearly 2 years ago, in May 2019, and Cardiff was among the first places in the UK to get 5G, or Pin-Peg, sounds much better in Welsh, I think. Either way, as the name implies, this new G is the fifth in a succession of new generations of mobile technology that have emerged roughly once each decade since the early 1980s. So far, each new G has been used primarily to connect users' mobile phones. But each new G has also changed the game in at least one important way by delivering a key improvement over the previous G. It's enabled a key innovation in the service proposition. And 5G is no exception to that rule. Indeed, 5G is the first new G to deliver several distinct new improvements. And those improvements, in turn, enable a multiplicity of innovations in the application of the technology. 5G is also the first new G to be designed for connecting a wide variety of device types, not just smartphones. And that also opens up new territory for mobile applications. Before I get into talking about those new capabilities of 5G, we used to have a brief review of the previous mobile Gs so that we can root our understanding of what 5G can do in the context of how mobile technologies evolved so far. Now, the first generation of mobile, 1G, emerged during the late 1970s and early 1980s. Describing it as a single generation, though, gives a misleading impression of uniformity. In fact, a wide variety of different technologies were used in different parts of the world. All of them were incompatible with each other. But one thing that all of the 1G technologies had in common is that they used analog signaling, which is inefficient at using radio spectrum to carry signals. For example, think how many more channels you get through your TV aerial today with digital TV than you did in the days of analog TV. Now, all this meant that in the early 1G phones and services were bulky and inexpensive, and that a mobile network cell could only support a small number of users concurrently. Now, this in turn limited the mobile customer base to few business people who could get so much benefit from making phone calls on the move that they were willing to pay a lot of money for it. That started to change in the early 1990s with the second generation of mobile networks, 2G. The industry was learning the lesson that huge benefits could be had through standardizing the technology used in mobile networks. For 2G, every country in Europe adopted GSM, which stands for the French phrase Groupe Spécial Mobile, although the acronym was retrospectively changed to mean Global System for Mobiles, in a forlorn attempt to persuade the Americans to adopt it too. 2G mobile was still purely for making mobile phone calls. But unlike 1G, 2G used digital signaling, which meant that far more users could be connected at the same time. Digital signaling also made the phones smaller and lighter, and the economies of scale enabled by the use of a standardized technology made 2G phones much cheaper than 1G phones. These factors, in combination, meant that with 2G, mobile phones were no longer the preserve of business people and the rich. 2G brought mobile to the masses, and the masses adopted it avidly. Everyone wanted a mobile phone, and by the end of the century, most people had got one. In the early 2000s, the next generation of mobile, 3G, started to expand the capabilities of mobile phones. As well as phone calls, 3G supported the use of mobile phones to make video calls and to access the internet. These things were certainly novelties, but they were also something that most people didn't really feel the need to do when 3G first emerged, especially not if they had to pay a lot of money for it, which they did. The implementation of video and the internet in early 3G phones was also rather primitive and cumbersome to use. So, although the mobile internet started with 3G, it didn't really catch on for most of the 2000s. That started to change when the iPhone appeared in 2007, showing people how much easier to use the mobile internet could be. But the services were still expensive, and you typically paid by the minute, and that continued to mute adoption. It was 4G, which first came to the UK in 2012, that really unlocked the mobile internet. By then, the emergence of YouTube, Facebook, and other internet content sharing services had led to internet traffic being dominated by video. You could use internet video on 3G, but it took some perseverance, with long waiting times and frequent pauses while the video buffered to catch up with the connection lag. Basically, wasn't much fun. 4G changed all that. It was the first mobile generation to be designed for internet access, with much higher data speeds than 3G could deliver. The new generation of 4G smartphones were also designed primarily as internet access devices rather than telephones, which made the user experience less cumbersome and more intuitive. Mobile video, and the mobile internet more generally, became a pleasure to use, and users adopted 4G much faster than they adopted 3G. Today, the vast majority of mobile subscribers in developed economies are using 4G phones and networks. 4G was also the first generation of mobile to see the same technology standard adopted worldwide. The Americans had finally seen the light. And all that brings us at last to 5G. Like 4G and 3G, 5G brings faster internet access speeds to mobile phones, but it also does a great deal more than that. As well as faster data rates, 5G also delivers lower latency, which means faster response. 5G also enables a much larger number of devices to be connected to a mobile cell site. And perhaps most importantly of all, 5G supports guaranteed performance by reducing the impact that large numbers of users have on each other's quality of service. These capabilities, in combination, are taking 5G far beyond smartphones. They're turning the mobile network into a connectivity fabric for sites like factories, airports, seaports, smart cities, and yes, smart towns. And now, as promised, a bit more about those new capabilities of 5G and why they're so important. 5G will be rolled out in a series of phases, each of them associated with a distinct set of capabilities, and each phase enabling new applications of the mobile network. Phase 1, we're in now, is called Enhanced Mobile Broadband. Customers of early 5G services are getting data rates of several hundred megabits per second. Further enhancements will eventually take 5G data rates past the gigabit per second mark. Now, with data rates in this range, the mobile network can support applications like streaming of high-definition video, real-time big data analytics, and the sharing of high-resolution images such as medical diagnostics and engineering drawings. Phase 2 is called ultra-reliable low latency communications. Now, latency measures the time taken for a signal to travel from source to destination in the network. 5G will reduce that time from the 50 to 100 milliseconds that are typical in 4G networks to 10 to 20 milliseconds, and eventually to single digits. This will enable mobile networks to support applications that have not previously been possible. Things like online virtual reality, real-time automation, and remote command and control of things like construction equipment, drone aircraft, and robots. Phase 3 is called massive machine-type communications. A 4G mobile cell typically has the capacity to support between 10,000 and 20,000 simultaneously connected devices. In a world where most mobile connected devices are smartphones, that's enough. But eventually, smartphones will be outnumbered by the sensors, actuators, and other devices used in Internet of Things applications, like road management, waste management, and warehouse automation. As the number of such devices grows, the cell sites they connect to will need to handle many more connections than they can support today. So this third phase of 5G capability will take the connection capacity of cell sites into the 50 to the 100,000 range, and then to several hundreds of thousands. Overlaying these new capabilities of 5G is a concept known as network slicing. Now, the idea of network slicing is that devices, applications, and systems can be provisioned with their own virtual instances of the physical network, with characteristics optimized to their particular needs. With network slicing, each of these applications, running simultaneously, connected to the same radio access network, will see a virtual network whose characteristics are tailored to its requirements. Crucially, those characteristics are unaffected by what other users are doing on the network at the same time. So with network slicing, mobile networks will, for the first time, be able to deliver the levels of reliability that critical applications in smart towns will need. And with that, we'll conclude our brief history and biography of 5G. I hope I've managed during the last 10 minutes or so to explain clearly what makes 5G different from the previous generations of mobile and why those differences are significant in the context of smart towns. Thanks very much for your attention.
Thank you very much, John. I want to stop sharing your screen.
Oh, yes.
So I know more now about the Gs. I probably have more questions as well. So just a quick question. When would we expect 5G to be as prevalent, as 4G?
Well, it's a complicated question because, as I just explained, there's actually a series of phases of 5G. But if we're talking about just pure coverage of 5G, and we take 4G as a precedent, which is reasonable given the circumstances, then we probably will be up to the sort of 80–90% population mark coverage by 2024, 2025, certainly by the middle of the decade. Now, of course, population and geography are different things, and there is a shift at the moment towards, by some operators anyway, towards trying to talk about geography rather than population. And that will be more important in 5G because a lot of the things connected to 5G won't be people's phones. So it's, if you talk about geographical coverage, it will be much further out into the 2020s before we start to see the majority of geography covered. But the other important thing about 5G is a movement called private mobile networks, which is starting really to gain some traction now. And what that means is potentially, if you've got a factory or an airport or something that you want 5G coverage on to do some of the things you can do with it, you can actually build your own. This has not been very easy to do in previous generations, but now that we're getting some access to suitable spectrum, Andrew talked about spectrum earlier, there's now this possibility for towns and for companies to build their own 5G coverage if they have an application that really needs it.
And there's a lot happening around 5G here. I'm in the Menai Science Park in Gaydra and Anglesey. So we have some 5G specialists here, which I won't explain further because I'll probably get the detail wrong, but there are 5G developments here in North Wales. Okay, so thank you, John.